Okay. So, thank you to all to see our videos. Today, I will explain another topic, that is 2 to 4 line NAND gate decoder. Previously, I discussed regarding on 3 to 8 that is decoder. Now, I will discuss that is 2 to 4 line NAND gate decoder. Okay. So, last class also what happens when I did that is a 3 to 8 decoder, one concept also I forgot it to explain. Here you see, whenever you create that is a 3 to 8 decoder, one enable is required to enable that is which output will get it. Okay, one enable is there actually. Here one enable we have to draw for each AND gate to get that output. These are the that is missing in the last class. You please you just consider this one additional, that is a connection enable. So it will complete that is a 3 to 8 decoder. Okay, today I will consider that is 3 to 8 AND gate. Previously what happens, we will always last 2 decoders we will discuss, that is 2 to 4 decoder, another is 3 to 8 decoder. In that case we will consider we have already considered like with the base of that is a AND gate. With the help of AND gate we design that decoder. But today we will consider that is a NAND gate to make that is a 2 to 4 NAND gate decoder. Okay, how NAND gate also used for decoder. Okay, so that is we will discuss now. Now we will design how NAND gate decoder will design. Very simple way, same case, but instead of an AND gate we will consider NAND gate. Okay, so now we will start. Let two inputs like A1 starting from either A0 A1 or A1 A0, doesn't matter. Here A0, similarly one part is that is a direct input, another part is what inverter, as you like. You design different ways or same way, similar case also doesn't matter. Okay, so here very simple here we can consider one part is that is a inverter, another part is a direct, that is the direct data we can consider. Since here is a two input A0 and A1 input, okay, how many output we can get? That is 4 output we can get. Okay, the 4 output defined through 4, that is a NAND gate, because here consider only NAND gate. 4 NAND gate we will consider to get 4 output. Okay, now we see very simple way, I will show you like this. Okay, 4 NAND gate we can get it. Okay, so now how 4 NAND gate to find that kind of a output. Okay, 4 NAND gate. Now we will see that is these 4 NAND gate you see defined through D0, D1, D2 and D3. Okay, these 4 NAND gate defined through in this way. Okay, so now we will design and connect which input to which output. Okay, so here you see that is a support D0, then what happens, we have to use that is first similar case, previous case 0 0 0 1 and that is 1 0 1 1, like this different connection you have to provide, like a first connection to here. Okay, that is a 0 0. So here also that is a we can consider 0 0. And another also enable also we can give here one enable. Okay, E for enable also consider in this manner. Okay, for all that is that is a NAND gate. Now you see one part is a enable, other part is our input in this way. Okay, it is a 0 0. You see, very simple way. It is a 0 0. Okay, 0 0. Here is a 0 1. Here is a 1 0. Okay, here is a 1 1. Okay, so these four category of output you can get it. But how it will activate? Then I will show you how it will activate based on that inputs with as well as that is enable. Okay, now we see here 0 0. Next is 0 1. 0 1 means what? For example, we will consider A0 is 1. Okay, here is A0, here is A1. Right hand side A0, left hand side A1. Then what happens? We will also consider in this manner. Okay, A0, that is A0 is 1. A0 is 1. Okay, directly we come to here. A1 is 0. So if A1 0, so directly connect to here. Okay, in this way we can also connect. Okay, another way. Next is here similarly 0 1 0. It is a 1 0. If it is a 1 0, then what happens? We can define another way. How? Here is 1 0. A0 is 0. Here you see A0 is 0. If A0 is 0, then you see how it is defined. Now A0 is 0 means here we connect here in this way. A0 is 0 and A1 is 1. Obviously this part will be here like this one. Okay, and another also here you see, here also whenever D1 activate, here one enable also will provide. Here also one enable also provide to D2. Here D1, here D2. Similarly, another enable also provide to D3. Okay. Next, here is a 1 1. You see all of you, that is here, that is a 1 1. D3 will be 1 1. That input is 1 1. How to get here? Very simple. Here is a 1. Okay. Here is a 1. And A0, A2 is 1. A0 is 1. So obviously we will collect from here. That is here will be 1. Here also we can collect, because you see this is 1, because this is 0. This is 1. Here also we can collect. This is 1. Okay. This is 1. This is 1. So in this way we can define. Other way also we can define. Okay. So now you see what are the connection? Very simple here. A0, A0, A0 0, A1 1. You see A0 here, A0, that is I will explain again. A0 0, A0 here it is 0, because this path we have to move. Okay, we have to move. That means 0. A1 0, here also this path we have to move. That is 0. This is 0. This is 1. Similarly, here 0, here is 1. Based on that, how data pass from A0 to A0 or A1. So based on that we have to connect. Here is A0 is 1. If A0 is 1, you see A0 1 means this path will connect. Okay. A1 is 0. That means through inverter A1 0. Through inverter we can define here. Similarly, A0 is 0. A0 is 0 here. It will come 0. Here is this path. It will come 0. Next, A1 is 1. A1 means here. A1 is 1. A1 means here. You see, very simple way. It is 1. It will come 1. Sorry, here. A1 is 1. A1 is 1 means here A1 is 1, A0 is 0. Here A0 is 0. 0, 1. It will convert 0, 1. Okay. Here is 1, here is 0. Here is 1, 1. 1, 1 means what? A0, 1, A1, 1. So, here you see A0, 1, A0 come through in this manner. Okay. Very simple here. In this manner, this is 1. And A1 also, it is 1. Okay. After that, just enable. This enable, we have to define or design for this particular 2 to 4 line AND gate. And whenever you go through AND gate, you see this is the NAND gate with you see the bubble we have to mention. This bubble make as a NAND gate. Okay, this is a NAND gate. Without bubble, we can consider as a AND gate. If bubble is there, then we can consider as a AND gate. Sorry, NAND gate. Bubble is there means NAND gate. Without bubble, it will be AND gate. Okay, this is the basic design for that is a 2 to 4 line NAND gate decoder. Okay, this is the design point of view. I draw this diagram. Now we will also define that the truth table for this that is a 2 to 4 line decoder. How it will be represent. Now I will draw this particular this 2 to 4 line truth table. Okay. So very simple way I will draw this line. Now I will draw this line like suppose here we can write a truth table. What to write? That is a truth table for and that is a 2 to 4 line decoder. 2 to 4 line decoder. Okay. So now how will it that is create that truth table? Okay. Very simple. We will draw. Very simple. That is a one line and another line also we can draw. How? Now we will see very simple. First one we will see enable. Okay. First one we will see enable. Okay. Very simple way. We see that first one is enable. Second one it is A1. Okay. And next is A0. Okay. Next is A0. And now start output. Since two input A0, A1 enable and here D, that is D0, next is D1, next is D2, next is D3, it is D3. Okay, these 4 output and 2 inputs we will just consider. Then how truth table define the output based on input. Okay, now we see if we go through enable, you see very simple way. Whenever you go through enable, very simple way you see. If we go through enable, you see if we provide 0, very simple way. If we provide 0, enable having this inverter. If we provide 0, output will be here 1. Okay, that means whenever 0 provide, that is output 1 and it will enable which NAND gate will activate. Okay, that means E0 activate this NAND gate. If E1, for example, E is 1, if E1 output will be what? If it is 1, output will be 0. That means inactive all data. Okay, that is the merit and demerit of enable. If enable is 0, then output will be 1. It will activate which NAND gate will be activate. Which NAND gate will be active. That is defined. If 1, output will be 0, but all NAND gate will be inactive. Okay. This is the basic concept regarding on enable if we go through this enable structure. Okay. Now we see very simple way. I will show you also. You see very simple. If it is 0, then it activate. If 1, this is inactivity. Okay. Now we see how it will activate or not. Now very simple way. Since A0, A1 will take different values as previously 0, 0, 0, 1, 1, 0. Okay. Next is 1, 1. Okay. Like this we have already considered. Here what happens? 0, 0, 0, 0. If 0, 0, automatically what happens? Output will be 1. If E is equal to 0, I have already told, if E is equal to 0, then output will be 1. Then A0 and A1 input will be considered. If it is 1, I told, if it is 1, then whatever the value, it will be 0, 0. Okay. In that case, what happens? What will do? What is the output? You see. Now you will see. You see, it is E is equal to 0. That means it will receive A1, A0 value, A0, A1 value. Then what happens? It will activate D0 according to this previous formula. Means design. You see, very design. Whenever 0, 0, here 0, 0, D0. Means D0 will be activated with a NAND gate. But activate previously if AND gate, D0 will be 1 in previous case. We have already discussed that kind of a concept. Okay. Previously, if AND gate will consider, then what happens? Will consider in this way. If it's two or three gate, whatever the decoder will consider. Okay. Previously also we can also take it. Like a previous slide also we can consider. You see, very simple way. We have already designed here A0, A1, D0 is 1. If it's 0, A0, 1, A1, 1, then D1 will be activated. Next, D2 activated. Next, D3 will be activated. Like this. Okay. In 2 to 4 decoder. If we go through 2 to 4, that is NAND gate decoder, then what happens? Then we can consider this is, that is D0 will be 0, other will be 1. Reverse case. Okay. D0 will be 0, other will be 1. But if we go through AND gate, D0 is 1, other will be 0. Okay. So, reverse case, very simple way, reverse case you see. Here, D0, since it is a NAND gate, okay, since it is a 4-line NAND decoder, okay, 4-line, we can write NAND decoder. Then, we can define in this way. So, it will be 0, other part will be what? We can write other part will be, that is 1, 1, 1, 1, 1, 1. Since it is a NAND decoder. Okay. If we go through AND, there is no problem. It is 1. If NAND AND gate, it is 1, other will be 0. Since it is NAND, it will be 0, other will be, that is a what? 1. Similarly, 0, 1. 0, 1 means it will be 0. Okay, D1 will be 0. 1, 0. 1, 0 means D2. It will be 0. And that is 1, 1. D3. This will be 0. Okay. This part will be 0. D0, here 0. D1, 0. D2, 0. D3, D0. Other part will be, that is 1, 1. Means here 1, here 1, here 1. Here 1, here 1, here 1. Here 1, here 1. Okay. These are the 1, 1. But in this case, what happens? D0, D1, D2, D3. In this way, it will be 0 value. Okay. But what about to enable? Enable case, similarly, you see, if it is 1, it is inactive. Totally inactive. So, what are the A0, A1, A0? Okay. Other part, what happens? Also 1, 1, 1, 1. You see, because why it is 1, 1, 1? because since it's a NAND gate, so all part will be 1 1 1, because you see here D0 will be activate. How? If it is 0, these are inactive, because 1 1 1 is inactive, reverse case. Similarly, if it is 1, whatever the value will put, that is what happens? It will be 1 1 1, not it will be 0. If it is 0 0 means at a time D0, D1, D2, D3 will be activate. So that is not right. So automatically D0, D1, D2, D3 all are 1. Okay. So this is the, since it is the reverse case of AND gate. Okay, this is the reverse case of AND gate. So reverse truth table value we can get. Okay, NAND is you can write NAND is opposite of AND. Okay, or opposite of AND, or we can write that is AND with a NOT. Okay, AND with a NOT. We can also define in this way. So different ways we can define. That means whatever the AND gate with a NOT logic apply with the AND, then we can get a NAND. Okay, this is the basic concept regarding on this particular, that is a NAND decoder. So this is the basic concept. I will tell you how to design 2 to 4 line NAND decoder. This is the basic that is a truth table I define here. I hope all of you understand this NAND decoder. All of you previously we have already discussed, that is 2 to 4 that is AND decoder or simple 2 to 4 decoder. But if we go through NAND decoder, some value is changing accordingly, since it is a AND with a NOT. Okay, that means a negative value of AND we can consider as a NAND. So this is the basic concept, this is the fundamental concept how to design the 2 to 4 NAND decoder with a truth table. Okay, so thank you very much. Thank you very much to watch these videos, and like it and subscribe my channel. Thank you to all. Thanks.